All right, just some announcement quickly. Okay, let's go over them. Lab number 1, you have seen the marks for the report already. For the programming part, I'll release it by Friday. Okay, I'll do that as soon as I can. Okay, about the midterm. So for coverage, this section here, we're a little bit behind the other section, but I'll try to cover everything you should know for the midterm by the end of Wednesday. Basically, what should be more to be covered? We need to finish up inheritance, also generics. Okay, and then there will be another review session by myself, 3 p.m. this Friday. Check the Moodle announcement. I think it's Lausanne Building B. The double check. Okay, 3 p.m. And for lab number 3, it's going to be released tonight, but I did just send a Moodle announcement just before I came. So there is a tutorial series I just made today. Basically, you have to go over that as a pre-study before you try lab number 3. Lab number 3 is going to be something very different from the previous 2 labs. So you got a chance to work with a large number of classes and try to really have a separation concern between model and user interface. So that's something I would like you to try. Okay, so I would say before you receive the instruction for lab number 3 tonight, try to start with the tutorial series. It's very self-contained. It does walk you through step by step. Okay, and then one thing to note, since we got your midterm next Wednesday during the lab session, so that means before your lab number 3 is due, tomorrow is your only lab session you can get help from the TA. Of course, I'll try to host our office hour to help you as well, but what I will advise for tomorrow, before tomorrow, at least finish the tutorial series. It's about 2 hours long. Try to manage your time before tomorrow. Finish the tutorial series. I will be in the lab session tomorrow to help you make some progress on lab number 3. You got about 2 weeks to do it. Okay? Okay, now, for today, I would like to first of all finish up the topics for inheritance, and then we'll go on to generics. Okay, let's see how far we can go, and then also Wednesday. Yeah. If you got any other questions about the course materials, drop by office hour or just come to Friday's session. Okay. Okay, let's now go on to where we left off before the reading week. Okay. So now one thing I would like to just tell you, at the end of the inheritance slides, there is a table that looks like this. Okay. Don't be too terrified. So for your benefits, I would suggest you don't memorize anything from here. We are trying to understand the principle and then derive the rules accordingly. Okay? So should we take it or? Okay. I'll just ignore that. Okay. Yeah. Okay. All right. That's good. All right. Okay. So this table here is at the end of the slides. So we'll go over all of them eventually. I'll give you one example. For example, the first one. Whenever you see any assignments like x is assigned to y, let's say x and y, they are simply just reference variables. By the principle we learned before the reading week, how do we know if x is assigned to y should compile or not? Right? What we said before the reading week. For example, if you have, let's say x is students, and also you have y being, let's say, resident students. In this case, x is assigned to y. As we learned, it should compile. On the other hand, if we try to say y is assigned to x, it shouldn't compile. We explain the intuition and the rationale behind, so you can review the lecture if you need more idea. But now I want to go straight to the rule, how you can judge, in case you got asked in the midterm or in the final. Basically, every time you have an assignment like this, you have the assignment symbol over here, all you got to do is to check the static type. You don't worry about the dynamic type when you want to judge if something compiles or not. Look at the static type for y. In this case, it's resident students. And look at the static type for x. In this case, it's students. And ask the following question. Is resident students a descendant class of students? In this case, yes, right? Okay, you can just think about the hierarchy students, which is ancestor class of resident students. So in this case, it's yes. But if you try to do y is assigned to x, it's the opposite. So it's false. Okay? Should I really, I don't like it to be interrupted. Okay. If you raise again, I'll take it. All right. Okay, any question about this? That's what we did before the reading week. Okay, so now don't be too terrified by the fact that it's being symbolized. It's basically the intuition we have been talking about throughout the class last time. Okay, we'll go more as we go through. So now let's go to this fragment of code over here. Just talk about casting. Okay, very quick review. So now if you look at this fragment of code over here, and then I'll also talk about the syntax for cast very quickly. Okay, let's look at the code over here. Start from here. Okay, so we have a variable called Jim of type students, static type. Also we have rs, and the static type is resident students. Okay, we can apply our rule right away. If you try to say, first of all, rs is assigned to Jim. The static type for Jim is students. The static type for rs is resident students. And we know very well this shouldn't compile. Agree? So now we want to, basically this example is showing you how inflexible the compiler is. Because after the previous line over here, Jim being a student object is really pointing to a resident students object. Really is. Okay? And also, for any resident student, they should have an attribute called premium rates. They should, right? But now, the problem is really about this line over here. When we say rs dot set premium rates, in this case, we really want to set a premium rate for Jim, and we should be able to do it, but somehow the compiler will just fail in the previous line. Okay? So now this is something about undecidability for tracking the dynamic type for any variable. That's why we said, for you as a programmer, if you are very certain about the dynamic type for this particular variable at this point, you can do some casting. Okay, that's why we got a syntax over here. Okay, let's go over the syntax very quickly. So the concept is really the same. You can definitely find a direct correspondence in Java as well. Okay, let's just go through very quickly. First of all, you can see that over here, it's a check assertion. So check some Boolean variable. If it is true, then you do the following. If it is false, fail the assertion at the runtime. Okay? And then this expression over here is a Boolean expression over here, the whole thing. Okay, let's try to understand that. When you say attached, it's basically like an instance of in Java. You're basically trying to see if the runtime dynamic type for this particular expression over here, in this case Jim, is Jim's dynamic type being resident students. If it is, you're going to do a cast over here. You're going to cast that this particular object over here into another variable called rsJim. So you're just introducing a new variable. But the difference is as follows. When you talk about Jim over here, Jim's static type is simply just students. So I will put S just beside Jim over here. However, all right. Hello? Hello? No one here? I think we just ignore. I don't think I'm allowed to just leave it off. Okay, anyway, we'll just ignore that. Doesn't need to be anything urgent. Okay, so now when we talk about the previous one, Jim is of static type students and dynamic type rs. But now if you look at this new variable over here, here's a crucial difference. As soon as we do the casting, we change temporarily the static type. Okay? Basically what we have is as follows. Let me write in different color. rsJim is simply just another variable over here pointing to the same objects. However, since we are trying to cast this variable over here into this type, so the static type is different. Okay, so now let me write it besides that. So now you can see the static type for rsJim would be rs. And when we talk about static type, it's really about expectation. What features can you call on that particular variable? So now you know that for Jim, because the static type is s, so you cannot call premium rates on Jim. However, now rsJim is of static type rs. Of course, you can now call the premium rate or set premium rates. That is why after the cast, you can actually say rs.set premium rates 1.5. So that is fine. Questions? Yeah. Yeah, so you can think about, yeah. basically, it's more like an instance of check. Okay, over here you can see attached over here is instance of. You can think about. Okay. Okay, attach is basically like an instance of. We're just checking to see whatever expression, which can be a variable in this case, whatever variable it is for Jim, is the current dynamic type of Jim, which is RS, an instance of resident students. That's what we are checking. If it is, we're going to cast that variable over here to RS Jim. Make sense? Yeah, okay, think it this way. Okay, now let me just do it again. Okay, Jim over here is pointing to a resident students objects. That's how we start with, right? And then we also have the additional information. Jim is of static type students. So that's why we got students over here. The fact that Jim is of static type students, that means we can say, for example, you can see the hierarchy over here. Whatever that's defined for students, we can call on Jim. For example, we cannot say Jim does set premium rates. We just cannot. Okay, agree, good. So that's why if we are so sure that Jim is really pointing to a resident student's object, we can do a cast if we are so sure. Well, you're basically talking about this line over here, right? So over here, this line over here. Yeah, because over here we're saying Jim is going to be created by a new object of dynamic type resident students. That's what we're doing. You may want to review the lecture from before the reading week. That might be better. Okay? But what I can say is for this line over here, once you review the lecture before the reading week, you will see that this line basically is saying Jim is of static type students, and we are assigning that a dynamic type resident students. Okay, good. Okay, guys, any questions about the cast syntax over here? Okay, yes, question. Okay, very good. So you're talking about to what direction can we cast? That will be the next slide.
All right. So
yeah.
Does the the compiler throw an error when you try to do that?
We'll get there. Yeah. Basically, the question was, can you actually cast a particular object to its ancestor class or descendant classes? The answer is both. Okay, but we'll get there. We'll get there. I'll use a complete example to show you. Okay, but before I get to the next slide, any question about this? Okay. If you're okay with this, let's go on. Okay. And let me go back to the slides. So one thing to show you is, so this is, you can see the description over here, but it's pretty much like how you do it in Java, just instance of, right? And then do the cast. You can just go over the slides for this part here. Okay, so now, back to your question. What kind of cast can we, okay, there are two issues over here. Number one, when you see any cast in your code, how do you judge if the cast should compile or not? Number one. And issue number two, if a cast compiles, is a guarantee not to have any runtime assertion error. So there are two issues here. We'll talk about one by one. Okay? Number one first. Okay? Of course, this is just the general rule, which I'll lead you to read it. It wouldn't make sense if I had to read it out to you right now. Let's use example to show you. Okay, now what I will do is I will go to this example here. Let's go over one by one. First of all, let's remember this principle over here. Whenever we talk about static type, it's really about expectation. What features can you call on a particular objects? To decide that, you just look at the static type. So let's look at one example. Let's say we have a variable called myPhone. And the static type is simply, oh, nobody reminded me, right? Wow. Okay, should I repeat what I just said, or are you okay? How about I just repeat? Okay. So now when we talk about static type, it's really about expectation. Okay? Expectation simply means, for example, let's say I have a variable called myPhone, and the static type is simply iOS. Okay? Let me just use color to show you. If you look at the inheritance hierarchy over here, iOS is exactly over here. So this is the static type for myPhone. Okay? So this one over here is the static type of myPhone. Now, what do I mean by expectation? That means any feature that is defined at this level here for iOS and all the other features that are inherited from the ancestor classes for iOS can be called on this particular object. For example, you can see for this particular iOS class, we have a new feature called FaceTime. So you can say myphone.FaceTime. So it is OK. So myphone.FaceTime. It is OK. And also, we inherit a feature called SurfWeb. And SurfWeb simply comes from the ancestor class called smartphone. So we can also say myphone.surfweb. We can also call another feature from the ancestor class, which is called dial. So we can also say myphone.dial. So these are the expectations on this particular myphone variable of static type iOS. Everybody follow so far? OK. So now, the idea is very easy. Since we said for the cast, you're basically changing the static type for variables. That means you're changing the expectation. How can you change the expectation? You can either make the expectation more, or you can make the expectation less, basically. Okay? That's why we got something called upward casting or downward casting. Okay? So what do I mean by that? For this particular example over here, you can see iOS, it does have some ancestor classes. It also has some descendant classes. Try to think about the following question. If I try to do some upward casting, let me just use maybe a red. If I try to do some upward casting, for example, I can say, if I want to cast my phone into smartphone, am I trying to make my expectation less or more? Less, very good, exactly. But on the other hand, if I try to do downward casting, for example, I can cast iOS onto either iPhone 6s or iPhone 6s Plus. That's a downward casting. In that case, I'm really making my expectation more, because the lower the hierarchy is, the more features you can expect on the class. Okay, so far so good. If you grab that principle, then the rest will be easy. Let's look at the example together. So now, first of all, again, in this particular slide, I'm only talking about whether the cast will compile or not. Okay, so now the first one, let's say over here, let's first of all create some objects over here. Okay, for this line over here, we're saying my phone is pointing to a iPhone 6s Plus objects. Okay, it is pointing to some iPhone 6s Plus objects. And you can see that this guy over here is the dynamic type. I can tell you that for our discussion over here, the dynamic type is not relevant. It somehow just be there just to tell you that. But remember, if you want to judge if something compiles or not, you don't worry about dynamic type, only the static type. Okay? Let me just make a note over here. It's irrelevance. Not relevance for compilation. Okay, so now let's have a look at the first cast. So now we're basically saying my phone over here. Are we doing upward casting or downward casting in this case? Upward, right? Well, basically, how do you judge? First of all, look at the static type for my phone is basically iOS, and we're casting into smartphone, so we're going this way. It's upward casting. So that means we are making the expectation less. Okay, now let's have a look at the following. Before we say that, we used to be able to call myphone.FaceTime, myphone.surfweb, and myphone.dial. So now the new variable after the cast is called SP. Okay, just called SP. So now let's think about, can we say, I'll put it here, can we say SP.FaceTime? No, right? Why? Because you can see SP is of the static type smartphone, right? So now, smartphone does not have the FaceTime, which is only existing in the descendant classes. So you can see the interesting thing is really the following. SP over here is pointing to basically the same objects, but the static type is different. The static type is simply just smartphone. On the other hand, for my phone over here, my phone was declared to be iOS. Okay? You can see these two variables are pointing to the same objects, the same. However, their static type are different. That means your expectation on them as a client will be also different. Somehow, because the smartphone over here for SP is at upper in the hierarchy. So that means there are fewer features you can call on SP. In which case, you just cannot call as FaceTime on SP. Is it clear? Good. Let's do another example over here. Let's see over here, we do the opposite direction. Let's say over here. And hopefully that's obvious to you, we're doing downward casting. How do you judge? Again, since we are saying my phone over here, and we know that the static type is simply iOS, we're casting that into iPhone 6s Plus. So that means we're doing this way over here. It's downward casting. That means we're making more expectation. So now what does that mean? That means what we can do now is, let me just write it out. That means IPS plus, so IP6S plus, is also pointing to the same objects, but the static type is different. The static type is simply iPhone 6s plus, okay, the static type. That means we can call one more feature on that. For example, let's say for iPhone 6s Plus, if you have maybe a feature over here, let's call 3D touch. Let's assume. Let's say there's a new feature over here in this level. So that means over here you can simply call IP6s Plus dot 3D touch. Okay, so far so good? And we only talk about compilation. But now my question for you, any question up to here? So now let me summarize before I just answer your question. For the casting to be compilable, you can only do upward casting to make the expectation less, or you can do downward casting to make the expectation more. Either way, both compiles. Yes, question. Good question. Okay, basically it's as follows. Let me just try to rephrase your question a little bit. Guys, okay, let's have a look at this. Let's say we know that this particular cast will compile, no problem, okay? And because it's downward casting. However, when you try to execute this block of code, what's going to happen? Think about this. In this case, IP6s Plus is also pointing to this particular object. What's this object actually? It is still just an iPhone 6s, just an iPhone 6s Plus, right? Is it going to work when I call 3D touch? Yes or no, in this case? Yes, right, because we said iPhone 3D touch is over here. However, it's not guaranteed you will always be available. I'll show you one counter example in the next slides. Okay? Can we, it's really annoying. Well, what about just put it here like that?
Oh, I did. It still rings.
Really?
Yeah.
Wow. Unless we cut down the power for the room. I don't know. Okay, anyway. Yeah, sorry about that. I should really complain to the lecture room. Okay. Yes, question?
Sorry, I just have one question. What again was the reason why we said that for the first case it's not relevant for compilation?
Yeah, good. Okay, now let's just mention another angle. You can see that when we try to decide whether this line over here, this is the first case of casting, and also the second case of casting. When we judge to see if both casts should really compile, we only look at the static type for this variable here, and then look at this type over here, and then decide whether there's an upward casting or downward casting. If it is either case, it will compile. We didn't really look at the dynamic type. Not really. So as far as judging the compilation is concerned, you do not worry about dynamic type. Okay? However, once things compile, when you execute the code, you may have to worry about dynamic type. Okay? So now let's look at another case over here. The same hierarchy over here, but let's look at things over here, right? Now, let's have a look at over here. So now we want to know, I can tell you every cast over here compiles, every cast. However, some casts, when you try to execute it at the runtime, it is not going to survive. It's just going to have some contract violation or just assertion error. Okay? Let's go over one by one very carefully. Now, let's see this. This line over here, we declare mine as Android. That is the static type. So what I would do is I'll simply put Android over here and Android over here. So now, in order to make a cast that will compile, how many choices do I have in order to compile? I heard 2? Many more. So here's my question. In order to do a compilable cast, how many options of classes do I have? I heard 7? 8. Maybe you didn't count Android itself. Okay? You can also cast it to itself, even though it's not that useful. Okay? So now that means you can cast either this way. If you try to do upward casting, you can cast to its superclass. You can also do downward casting, in which case these are the classes you can cast that into, also including itself. Okay, so these are all the 8 possible cases that will make your cast compilable. Okay, no problem, as we said. But the problem is, if you try to execute some of these 8 compilable casts, some of them might give you assertion error because you simply just cannot cast certain types to other type. Let's see exactly why. Okay, let me just undo this and then I'll show you. So now in order to see the behavior at the runtime, now we have to bring dynamic type into the context. Okay, let's now see what the dynamic type is. So I'm going to use a different color here. You can see that over here, when we say this line over here, so Samsung is the dynamic type, okay, from this line. So let me highlight it. Samsung is the dynamic type. Okay, so now we have a variable mine over here. Let me just write it out. So mine is pointing to a Samsung objects. And also, we know that this variable is of static type Android. Okay, static type is Android, and dynamic type is Samsung. Okay, make sure it's clear to you. So now let's try the various cast all together. Okay, let's have a look at this one here. This cast over here, let's try if that will compile. It will compile, but let's see. Mine over here is of static type Android. I'll put A here. Is Android a subclass? Is this a downward casting or upward casting? Upward casting. I'll just put an up arrow. Upward casting. So that will compile, no problem. Okay. We'll talk about runtime in just a moment. Okay. Now, what about this one over here? Well, basically, that's actually what you lost the case, right? You missed that case. So here, Samsung, the dynamic, mine is static type is Android, and then if you cast that to Samsung over here, basically just to its own dynamic type. That's a downward casting, so that's okay. Downward casting, no problem. Let's try to see another one. This one will be interesting. This one over here, let me use a different color. Now, issue number 1, does it compile or not? What's the static type for mine? The same as before is Android. Now, are we doing upward or downward? Downward, very good. So that will compile. Compiles, no problem. Okay? Hypothetically, can I just assume? Let's say I do have a specific feature for HTC. Let me just call that HTC feature 1. Let's say that's just very specific to HTC only. So now, if we try to execute this particular cast at the runtime, I can tell you, even though it compiles, it's going to give you runtime assertion error. Can you see why? It's something to do with expectation, really. Okay, I'll briefly mention verbally, and then I'll show it to you. If this cast actually compiles, that means at the runtime, we're going to say HTC is actually going to point to Samsung objects over here, right? And then we know that the static type is going to be HTC, HTC over here. What's one of the expectation of HTC? HTC F1. Okay, so now if we try to say HTC dot HTC F1, is it going to succeed or not? No, because we're talking about Samsung objects over here. Samsung does not support this one here, even though it's a downward casting, but you're casting that to some class whose expectation simply wouldn't work for the dynamic type. So in this case, it's going to crash. Okay, that's why you got an assertion error. Okay, are we okay with this example here? Okay, let's do one more. What about this one here? Okay, for this one over here, apparently you can see mine is of type Android. And we are really doing downward casting, don't you agree? Okay, we're doing downward casting over here, downward casting, and we are trying to cast that to this particular class. Okay, it's a downward casting, so that will compile positive. But now it's going to fail at runtime for the same reason. Because for this particular class, which is lower than the dynamic type in the hierarchy, they might support some feature over here which is not supported in the dynamic type. So when you try to call that, it's going to fail. So that's why I'm going to get assertion error at the runtime. Guys, I'll take questions before you, yeah.
Oh, but that will only fail if you try to call that particular feature.
Okay, good question. There's something that's missing. Okay. So now let me just take this one for example, and the other one apply the same reasoning. Can we just consider this block over here? Let me just highlight it. Okay, let's only look at this line. The story is, this is the static type. Okay, let me just make it a little bit clearer to you. Okay. When we talk about this particular case over here, this is the static type for the variable. And since we are trying to do some downward casting over here, so it will compile. However, the actual dynamic type for the variable is actually over here. Okay? And it's, this scenario over here will correspond to something called class cast exception in Java. If you try something similar in Java, let me just mention that in case you don't know. It's called class cast exception. Okay, class cast exception, which means such cast is simply not going to proceed. Why? Let's prove by contradiction, like how we did for the intuition for the polymorphism. Okay, let me just write it out for you over here. Okay, let's say this. For this particular one, let's assume this cast, I mean the cast over here, this cast could succeed. So what does that mean? That means later on we can actually call galaxy, which is of static type over here. That means we can actually call galaxy dot, let me assume there's a feature f over here that's specific to this particular class. Okay? When I call this one, would fail. Because the dynamic type is Samsung over here, right? It's actually Samsung. And for this reason over here, it simply just wouldn't let you go through for that particular cast, even before you call that feature. Yeah.
Do you only get runtime failure for downward testing, or is it possible for upward?
That's a good question. The question was, for this kind of assertion error, can you actually have it when you do upward casting? The answer is no. For upward casting, you will always be safe at the runtime because you're actually restricting the features you can call. So you're not really creating any dangerous zone. But for the downward casting, if you cast to some class that have the expectation that's more than what your dynamic type is, it's going to fail at the runtime. Okay, yes?
Professor, so anything like, from Samsung to the variable, the right side of the tree compiles, right? And if you try to kind of cast it to the left side of the tree, does it compile?
Yep, very good question. Let me just try to make some visual guide for you. Okay, so now so far so good. Let me make a visual summary for you. Okay, What I will do is, let's now erase this part over here, just for this part. You know what? Let me keep the feature f over here, so you don't lose that information. Okay, this is what I would like to summarize visually. Let me use green color for whether things will compile or not. Okay, in order to make a cast compilable, you can either do upward casting or you can do downward casting. So that means all the A classes over here, you can cast them into. Okay, compilable cast. Okay, so also good. That's about compilable cast. But out of these, only some of them will actually be runtime assertion free, runtime assertion failure free. Okay, which ones? Basically, those have to be like this. Those have to be. Let me circle them first, and then I'll show you, like this. Only these will guarantee there's no assertion failures. Because whenever you want to talk about assertion failures at the runtime, you have to worry about the dynamic type. In this case, if you try to cast a variable to any class that is actually an ancestor of the dynamic type, you're okay. Okay? So the green one tells you which classes you can cast into without any compilation error. The red one tells you simply a subset, tells you which ones will be free from any assertion errors at the runtime. Yeah.
So if the compiler can say that these are the only classes that can compile, why can it not say the classes that are after the children classes when you try to run their methods, right? And like when you try to cast it to those subclasses? Yeah, because since we said before, compiler cannot keep track of the dynamic type. That is why you as a programmer, you have to be careful. You can easily fool the compiler by saying, I want to cast maybe my phone, which is of type Android, into, as we did before, maybe Galaxy, right? It's a downward casting, so the compiler knows nothing about what the dynamic type is. Okay? So, yeah, questions? Yes?
You do an upward casting and then do a downward casting, make it accepted.
Yep, that's a good question. Basically, the question is, you can, again, easily fool the compiler by doing some upward casting and then do downward casting. You know what? This one is a little bit sophisticated. I don't have the slide for now. Let me create one slide for this as an exercise, maybe in the beginning of Thursday. Okay? Okay. Yeah, that was actually very, very interesting. Yeah, I'll show to everybody on Thursday. Yeah, I'll do that. Okay, guys, any question about this? Yeah, before I take your question, I do have a written notes for exactly about these two issues over here. I'll send you the link. You can go over them, okay, in the written form. Questions?
So my question is, if you're casting, so the static type is of type Android.
Yeah.
But the dynamic type is of type Samsung.
Yeah.
Your expectations are features of type Android.
Yes.
Right? And you're going to get these in assertion violation. So you're going to get these types of exceptions.
Yeah. So the problem is, so you're right. So over here, the reason that we got assertion errors over here is for this particular type you're trying to cast into, it contains a feature over here which is simply not supported by the dynamic type of Samsung over here. You wouldn't get any issue because over here, okay, basically you're saying the following. Guys, let's have a look at this line over here, okay? I'll try to just illustrate over here. That'll be easier. Okay, well, question is a little bit long, so I'll try to illustrate. Okay, let's have a look at this line over here. This one is guaranteed to be compilation. It's going to compile. Also, there wouldn't be any runtime assertion error. Let's see why. So now over here, we have mine over here is going to be cast into Samsung. And also, it's going to be called Samsung, right? Let's have a look at, let me write it out. So we have Samsung over here. Okay, I'm just going to repeat the name over here. Samsung is going to be of static type Samsung. Okay, and it's going to point to the same objects, right? Okay, so now your question was, if I try the following, okay, let me try this. Let's imagine that over here, let's have the following lines. Okay, so basically here, after the cast, we can definitely use the Samsung over here. is of static type Samsung, right? To call any Samsung specific feature over here. Okay, let's say we have a feature G over here, for example, right? If I say Samsung.feature G, it is going to compile, first of all, because the static type for Samsung is simply Samsung. Of course, you're going to support it. But what about at the runtime? Is it going to be okay as well? Of course, because the dynamic type simply Samsung is guaranteed to support that feature, of course. On the other hand, before, if you simply say, let's say mine over here, if you say mine dot G, it is not even going to compile, right? Because the static type of mine is simply just Android, which does not support this downward feature G, right? So you can see the issues over here, right? Yeah. Basically, if you want to call more features, it is possible for you to do a cast, but be careful. Even though the cast might succeed at the compilation time, you might run into some assertion errors at the runtime. Okay, any more question about this issue here? It's quite tricky here, but yeah, try to get as much as possible and study the notes. Yeah.
But isn't Samsung using Android?
Samsung, what do you mean Samsung using Android?
Like, I mean, devices, the phone device.
Yeah, well, I would say we basically, whenever you want to answer this kind of question here for cast, you want to focus on the hierarchy we have, which is over here. So that's a class hierarchy here we have. So just focus on that. That'll be easier. Yeah. Okay, any more questions before I move on? Okay. If no, let's move on. So I've covered already 2 slides. Okay. I would say this might be the most challenging ones, okay, throughout the lecture. Hopefully you got it. Upward casting or downward casting, and see which one will actually compile and which one will compile but run into the runtime assertion error. Okay, let's do something slightly simpler. Okay, slightly. Okay. So now what I would like to do is let's consider another class over here. Let's say we have a class called Student Management System. Okay, and we have an array of students. Okay. So now I already said it over there, but I would like you to think about the following. Okay, let me just switch to iPad over here. Okay, I want you to look at this line over here. When I say SS, which is an array of students. So what does that really mean? Again, we are declaring something. When we are declaring something, it's just about static type. So what we are saying is SS at the runtime is going to point to an array of objects. And each one of them is just going to be of static type students. Students and students. Just a static type. However, what can be the dynamic type for each slot? How many possibilities are there, dynamic types? It can be either students, it can be resident students, it can also be a non-resident students, basically. Okay, but let's see how. Okay, let's see how. I want you to first of all make sure you understand the following. So now when I talk about SS, which is an array at index I, let's say I is a valid index for the array. So what's the static type for each element of the array? Basically, as I said before, since we declare SS as an array of students as a static type, that means every element in the array has the static type students. Let's make sure we understand this one here. That's how we declare. Okay? Once we understand this, I want you to consider another line. Okay? Now, let's say over here. Let's see this line over here. Let's say we got 3 different features. Okay? Now, if I have a feature called add students, and then the parameter over here is of static type students. Okay? And now, should this particular assignment compile or not? Since I talk about compilation, so what should we look at? Static type. Should this compile or not? Well, what's the static type for S? Students. What's the static type for SS0? Students. Student is a descending class of itself. So it will compile. Very good. This one is very easy. What about another one? Let's look at the second one over here. And now this is slightly different. We are declaring the parameter to be of a different static type. So now how do we judge to see this particular assignment should compile or not? Well, static type of RS, resident students, right? It's declared over here. What's the static type of SS0? Students. RS is definitely a descendant class of resident of students, so that should also compile. All right, similar reasoning for this one here, because non-resident students is a descendant class of students. Okay, so far so good. So now, okay so far? Very good. So now, the following question is for you. Let's say I'm trying to make a feature call. Let's say I'm trying to do SMS. Let's say SMS is a student management system objects. And we are trying to call add RS. Let's say we're trying to call this feature over here. Let's say over here. We're simply passing an object O. Can you give me some typing rules? When would this compile? Yeah. Well, you're saying if I give any objects of type student, would it work? Think about this, right? So now let me write it down, okay? This one is about pass by value. Yeah. Yeah, exactly. Okay, good. Okay, but let me illustrate that to you, okay? Let's now, let's look at that. Let me just repeat, add RS over here is RS of type resident students, right? And then we simply got do and then n. That's a feature declaration. And now we are passing O over here. Remember we learned about pass by value back in 2030, right? When you say pass by value, here is where the pass by value is going to occur. When we are trying to say I want to pass O as the input for RS, basically I'm doing the following assignments. I'm trying to say RS is assigned to O, basically. That's pass by value. And given that, we can apply our compilation rule. And the static type of O must be a descendant class of RS. In this case, it's resident students as a static type. Okay? Guys, follow? Yeah? If no, please raise your hand. Yeah? Don't follow.
So when you pass arguments to methods in IFL,
Mm-hmm.
always going to be passed by value.
Yeah, pass by value. Yeah, you only got pass by reference for languages like C. So when you actually pass, you can manipulate the address. But in this case, we cannot manipulate the address. Just a copy of the address.
So you're passing, okay, so what you're passing,
Mm-hmm.
the pointer to.
Yeah, like a pointer or the reference. Yeah. Mm-hmm. Okay. Huh? What if it is expanded? I think the same, for expanded, you just pass the value. I mean, the whole object, right? So there's no reference here. Wow, there's another discussion, right? Okay, so now, yep. Sure.
Although the slots within the array are
Mhm.
type student, they should technically take anything of type student or descendant.
Correct, that's correct.
The actual method has a parameter that requires you to have of type resident student or descendant of.
Correct, that's correct. So the type of the parameter is a very good observation. How you declare the parameter type over here determines what kind of arguments can you pass to the feature. So you can see you got 3 different possibilities. Which one to really declare in your class is a design choice. I do have a slide to show you what kind of design concern you may have. Okay. So guys, just for those of you who are maybe still a little bit lost, let me try to draw some picture for you. Okay. Now let's say we still got this feature called over here O. Let's say we try to add resident students O, okay? Let's say O is currently, O over here, the arguments over here. Let's O is just currently pointing to some resident students. Maybe, for example, the name is simply just Jim. Okay, let's say this, okay? So now what does it really mean when we are trying to pass the reference to this object over here, which is O? What does it really mean? That means as far as the feature over here is concerned, they're going to manipulate in terms of RS, not really O. Okay? So what it really means is RS is assigned to O. It's basically creating some aliasing. That means RS is also going to point to the same objects. But whether this assignment over here is valid or not is subject to some type checking rules, which we have discussed. Okay, any question about this before I show more example to you? Okay, you all right? Good. All right, let's have a look at some example here. Okay, now, okay, exactly what I said. Okay, so this slide we have already covered. So now let's see example. Let's have a look at this over here. And then what I want you to see is basically the same thing. Okay, we still got these four features here as before. But now, let's now consider a test, more like a client code. Now let's try different possibilities. Let's say we got S1, S2, S3. Static type is students at the top of the hierarchy. We got RS of type resident students. We got NRS of non-resident students. Okay? So now let's say we create a student management system, and then we create, let's say S1, S2, S3, RS, NRS. Okay? I'm going to give you different lines, and let's try to see if they will compile or not. Okay? Now, since we are talking about whether things will compile or not, does dynamic type matter? No. That's why I didn't highlight them. There's a reason. Okay? But let's see. Let's see the first one. Let's try a few ones to get a feel. Okay, that's exactly what we had. First one. If I try this, sms.add_s and s1, should it compile? If you think it should compile, give me a reason. Okay, try to be as complete as possible. Yes.
Okay, so the add as parameter takes in something of type student.
Yep.
And the slot within the array are of type student.
Mm-hmm.
And S1 is of type student. All the static types match. So it should
Yeah, when you say static type match, that's a little bit vague. Okay, let me try to correct you a little bit. Let me go back here. This is the ideal answer I would expect from you. So when I say SMS dot add students, and then I say S1. Okay, this is what we should look at. First of all, static type for S1 is students. And then what's the formal argument type for add S? It is students. And students is a descendant class of students. That is why it compiles. Okay, that's the complete reason. Okay, good.
You're looking for the keyword descendant.
Descendant, yeah. Well, that's always that, as long as it can boil down things into an assignment in a primitive form, you are subject to the rule that we have been talking about, right? Okay, let's see more example before I'm convinced you get an idea. What about this one here? Add S2. Compile? Yep, for the same reason. And this one also compiles. Okay, let's see something more interesting. What about this? Well, and anyone else want to try? Yes. When you say RS, the static type is resident students. And the formal parameter type for add S will be students. Resident student is a descendant class of students. Very good, very good. Let's try more. How about this? Yeah, because non-resident student is also descendant class of students. And now let's try this. How about this? No, right? Okay, why? Well, intuitively, you are expecting a resident student, but you are passing a students. That's not good. So the complete answer should be static type for S1 is students, which is not a descendant class of the formal argument type for add RS, which is resident students. Okay, just not going to work. Okay. How about here? Same thing. Very good, same reason. And now, what about this? Well, you can see the RS is of type resident students, which is a descendant class of itself for the formal argument type. Okay, that's fine. How about this? No, right? NRS, static type, non-resident students. What do we expect here formally? Resident students. Okay, doesn't pass the check. Okay, hopefully you get the idea. You can see the idea is really pretty much consistent. We're telling a story, really. We start with substitution using assignments, and we try to talk about different scenarios, which can all be boiled down into assignments. Okay? Okay, now let's get to something that's even more interesting. Since we know we can have stuff like this, let's just go back to, if you try to look up the slides previously, without the inheritance, how can we create an array that can accommodate students, resident students, and non-resident students? The answer is you cannot, because they're simply different types without the inheritance. But now, since we have an inheritance hierarchy, you definitely can have a polymorphic array, so-called. Let's see exactly what I mean by this. Okay, what I will do is, let's look at this slide over here. Okay, let's try together polymorphic collection. Okay, again, we have our student management system over here, and then we have students linked list, let's say, and also static type is simply students. Let's see exactly how polymorphism will work. And this, we actually see 1 or 2 design patterns after your midterm that will explore exactly this feature. So let's try to understand this properly. So as students is just as before, okay? So we're just choosing the most accommodating version, just taking any student's descendant classes as the parameter, as the arguments. Let's say we also got register or, and then simply register course, okay? This one here is fine. So now if you look at over here, we simply say s over here, s.item.register, okay? So now I have a question for you. Have a look at over here, s. Question for you, what's the static type for s? Static type. Students, how do you know?
Depends on the parameter you look at, right?
No, parameter over here is course. It's nothing to do with students. Well, okay, this one is a bit tricky, but nothing too difficult. S is basically, well, s.item I should say, sorry, s.item. S is a cursor to some item in the students array. What's the type of students? Students, array of students. So the static type for this one here, s.item, the static type is simply students. Okay, that's how we figure out. And the next question, at the runtime, what can be the dynamic type for each student we're looking at? What can be the dynamic type? Well, given what we have seen in the previous slide, if you're expecting for the S students over here for any objects that is descendant class of students, that means at the runtime it can be a students, it can be a resident students, it can also be a non-resident students. Agree? So now let's see how this can occur at the runtime. So now static type is students. What about dynamic type over here? I would say it can be a student, it can be a resident student, it can also be a non-resident students. But let's see exactly how this can occur. Let's look at the client code. Now let's say we have, I'll draw a picture, okay? Let's start with the first one. Let's say, first one here. Okay, let's look at these 2 lines. Basically, I have RS is pointing to a residence, is pointing to a resident students. You can see RS is declared as resident students objects, and since we didn't have the curly bracket, that means dynamic type is simply the same, right? So now we have a resident students. And then the premium rate is simply 1.5. I would say premium rates is 1.5, and it's simply Jim. Okay, that's what this line does. And now, let's see the next one here. The next one over here, we have NRS, which was declared as non-resident students, and then we simply say creating of the same dynamic type, right? So NRS, different color simply mean they're of different dynamic type. NRS is pointing to an object of type non-resident students, and also Jeremy. And also the discount rate is simply 0.5. Discount rate is 0.5, like that. Okay, so far so good. And then we are trying to create, let's say, create a student management system here. And now these 2 lines are crucial. As we learned from the previous slides, we know that these 2 lines should compile, right? Good. because at S, formal argument type is simply students, which is very accommodating for any descending classes. So now, what's going to happen? First of all, let me say I have SMS over here is pointing to some student management system. And then one of the attributes is simply students. Okay? It's going to point to some list, initially empty. Okay? Now, what's going to happen after this line? Well, apparently, the item number 1 in the list is going to point to RS, right? Agree? What about this line over here? That means item number 2 is now going to point to NRS. And remember what we said before, the students, each element is of static type, students. But now the dynamic type can be either resident students or can be non-resident students. So this kind of array, where the dynamic types for its elements are different, is called polymorphic array. Okay? Okay, hopefully you can see it. You might have seen something like this in 2030, but possibly not really from the typing point of view. So now I'm just trying to show you the whole story. Okay? First of all, why you can do it and how it is constructed. And it is really important. Okay, let's go even further. I want you to look at, first of all, this line over here. And then I say SMS, the register all. Okay? That means according to the code over here, every student I'm going to register for a particular course, C. Okay? A particular course. Let me just say the course is simply called, let's say over here, let's say C is pointing to a course. What about just 3311, for example, for each student? Okay, apparently after register all, you can see for the very first iteration, we're going to say s.item.register. S.item for the very first iteration should refer to this object over here, right? And then we're going to register for this particular course. For illustration, I will say this somehow is pointing to this course objects, register. What about second iteration? If for the second iteration, s.item is going to point to this object here, NRS, right? And then we're also going to register NRS to the same course. Okay, so now here comes the interesting bit. When we try to do the following, I want you to look at these two lines. That's just one of them. First of all, look at this line over here. Does it compile or not? It should compile, right? Why? Why is that the case? Okay, let's, again, whether things compile or not, look at the static type. Okay, now let's have a look. SMS is of type student management system. And student management system does have an attribute called SS. This part is okay. SS is of static type students. Okay, that means this part over here is going to give you of type students. Okay, so far so good. And now is tuition a feature of students? Yes, indeed, it's one of the features we define. Okay, now the question is, when we call this, okay, as far as the compilation is concerned, that's how we decide. But now, which version of the tuition are we going to call? Remember, we got 3 different versions, right? At the student level, we simply calculate the base rate. At the resident student, we calculate using the premium rates. At the non-resident student, we use a discount rate. But now, which version do we use? Dynamic type, it depends on the dynamic type. In which case, resident student, right? Okay, so now you can see that over here, since we talk about object number 1 over here, which is exactly this object here, so that one is going to apply the premium rates. Okay, that's why you got 750. Okay, on the other hand, basically the same expression over here, it compiles for the same reason. However, the behavior at the runtime will be a little bit different, because since we talk about different position in the polymorphic array, so now at position 2, we are talking about this object here, which is non-resident students. So now when you calculate tuition, a different version of the tuition is going to be called using discount rate. Okay, that's why you got a different result. Okay, you can see over here, right? Yeah. Question here before you. Yeah, question.
Why would you call the resident student
Correct. But remember, tuition is actually good. As far as the compilation is concerned, we know that each element in the array support at least the feature that you can expect from the student class, which includes tuition. Agree? Yeah. So now, when you actually call the tuition feature at the runtime, which version is going to be called? According to the dynamic binding principle, the runtime is going to look at the dynamic type for each one of them. And now for position number 1 over here, is currently referring to resident students. That's why it's going to call that version of the tuition. And for position number 2, it's referring to this object over here. So it's going to call that version. Somehow, yeah, it's actually reused part of it, right? We calculate the base, and then further we apply. Yeah, well, we don't have to worry about exactly how things are implemented at the runtime. All we got to know is, since for position number 1 in SS is referring to a different objects, it is referring to a different dynamic type as opposed to position number 2. So that's why different versions will be called. Yeah, yes. Exactly. So static type is just about expectation, like what features you can call. Yes.
But the dynamic type actually determines what sort of overridden method is actually run.
Exactly. Okay, let me summarize exactly what you said. So for static type, it tells you what features you can call on this particular variable. For those features you can call, depending on what the dynamic type is, the corresponding version will be called.
Exactly. So in this case, because the array is type student, you're not able to go to the array and call like the premium rate.
Exactly. It's a very good thing. It's a very good point. So let's say, hypothetically, let's say if I try the following, I say s.item dot set premium rates 1.5. My intention is I want to set a premium rate for every student in the students array to be 1.5. Does it compile? No, it doesn't, because s.item, we know that the static type is simply just students. Student does not have the set premium rate. So exactly, yeah. Okay, again, the principle to judge if something compiles or not, only look at the static type. To know the runtime behavior, consider also the dynamic type. All right. Yes.
This might be a little unrelated, but when you're implementing like a descendant feature, is it possible to, as part of the implementation, call the parents feature?
Oh yeah. Remember, in Java you call super. In IFO, if you look at the previous slide, it's called precursor. Actually, we have been using precursor, right? So remember, in lab number 1, we show you how you can test the violation for postcondition. We simply, in the bad descendants, we call the precursor from the parents. Yeah, maybe look it up. Yeah. Okay. Polymorphic array? Yeah. Okay, sure. As a concluding remark for this particular slide, let's recap. What's really polymorphic collection? So it can be array, can be linked list, can be whatever structure you have. Basically, over here, point number 1, we declare the students linked list to be a linked list of students. So that means every element in the linked list has the static type students. Okay? And this is the feature for us to add a new student object into the array. And since the static type for this feature is very accommodating, that means any objects that's descendant class of students can be added into resident students or non-resident students, right? As we learned. So at the runtime, this is what we have. You can see even though let's say this is the polymorphic array we have over here, each slot, statically speaking, is of type students. That means we can only call student feature on each of the slots. That is why when you say s.item set premium rate, it's just not going to compile. Okay? But dynamically speaking, because each one of them is pointing to maybe a descendant type for the students. In one case, maybe resident students. In the other case, maybe non-resident students. So when you try to call a feature that can be expected from the static type, which is students, for example, tuition. So now in this case, maybe a different version can be called, depending on what the dynamic type is. So that's dynamic binding. Okay? Thinking through the issues here, we got quite many examples today. Thinking through, if you got questions, maybe ask me on Friday as well, or office hour. Okay. Okay, let's go on to the next one. Okay, everything has been said. Okay, one more topic. We talk about cast, we talk about feature arguments, we talk about polymorphic array. Let's talk about return value. Okay, return value. Okay, accessors or queries. The idea is just the same. I tell you what, it's very easy to think about before I show you anything. Here's the principle. In IFO, in IFO, it's a little bit easier for you to think about this issue here. In Java, it will simply say return the value, right? But now in IFO, remember, you don't have the return keyword. How do you assign the return value? You would say result is assigned to something, right? So now if I have a feature that returns a students, that simply means result is of static type students. If I have a feature that returns a resident students, that means the result is of static type resident students. And the rest will just be the same as before. But we'll see example. Yeah. How about see an example first? Okay. Let's have a look. Again, let's have a look at exactly over here. Okay. Again, the similar setup. So we have, again, students being the static type for each element in the linked list. And also we have this accommodating version for the as students. So now this is a new feature we're going to consider. The new feature. Get students. So we just talked about how we can add students. What about we also talk about how to get students? So now let's look at this feature here. It's a query. We just want to give some index value over here, and of course we check to see if that's valid or not using a precondition. And then what we return statically is a students. So now this means as if we declare the result to be of static type students. That's how you can think of it implicitly. So now everything should just make sense, hopefully. So now if you look at this line over here, should it compile? Well, static type for SS is index I, students. Static type for result, also students. Students is a descendant class of itself. So this will compile, no problem. But now the question is over here. At the runtime, what can be the dynamic type for result? Well, can it be students? Yeah. Can it be resident students? How is that possible? Well, thinking this way, the only way you can add students into the array is by calling this feature. Since this feature allows for a students object over here, which might have the dynamic types resident students, and you're assigning SS at position I, that means it can be a resident students. Okay? I will repeat it again. Okay? So now, we know that first of all, as the class is, as it is, the only way you can add students into the class would be into the array is by calling this feature here. And the feature argument is very accommodating. It's simply just students. That means at the runtime, since we talk about polymorphic array, you can add a resident students as one of the elements in the array, or non-resident students. And now over here, the way you assign the result is simply by assigning whatever it is pointing to at position I. So that's why it's going to be of dynamic type, can be of students, resident student, or non-resident students. Okay. What about see one example? How about that? Okay. Let's see one example. So let's say we got two lines over here to create. Let's see very quickly. Let's see RS is pointing to some. I'll try to do a little bit more simplified version for you. RS is of static type resident students. Dynamic type is just the same. RS. Also, we have NRS. So NRS is pointing to some NRS objects, dynamic type. Okay, after these two lines, and then we try to execute this line over here. That means we're going to add S, RS, add S, NRS. That's how we have a polymorphic array. So that means SMS is pointing to some student management system objects where we got a students array, and the first element is going to be resident students, right? And the first one over here, dynamic type will be this. And for the second element, after executing this line over here, is going to be pointing to some non-resident student objects. Okay? Now we got polymorphic array, just like before. Okay? Now let's have a look at what's going to happen here. let's have a look at over here. Let's execute this line before we get there. And then we also got a course, maybe C is pointing to, let's say, 3311. And then it's simply 3311 over here. And then we're going to register all the students in the array to the course. Okay? So somehow, let's imagine that somehow this student is registered to this course over here. This student is also registered to this course over here. So now, finally, let's consider these two lines. Let's have a look at these two. The first one, get students 1. Okay? What's the static type for get students 1? Static type. Students. How do I know that? Well, we simply look at the declaration for get student, which is students. What's the dynamic type? Well, position 1, resident students. What about get student 2? Static type. Students. Still, look at the declaration. What's the dynamic type for get student 2? Non-resident students. So that would be just a different dynamic type over here. So that's why, since dynamic types are different, so when you call tuition here versus calling tuition over here, it's going to call different versions, right? Okay, let me just write it down exactly. So over here, for this line over here, the dynamic type is simply resident students. And for this line here, the dynamic type is non-resident students. So that's why the version of tuition being called over here will be the version from resident students. And the version being called over here will be from non-resident students. Okay? Okay, guys, any questions about this? Okay, 5 more minutes, right? Okay. Yeah, I want to cover just a little bit more so we can have more discussion. How about this? About this or?
Yes, about this.
Okay, guys, please. Okay.
So in regards to the return type of if you're trying to get a student from the array, the static value of that return type is student.
Yes.
Right, but if you're trying to, let's say you have a local variable of type resident student, and you're returning actually something that has a dynamic type resident student, are you able to?
No, you got to do the cast.
Oh, okay.
You got to do a cast. Yeah. Okay. Now let's do a few more slides. Okay. So can save a little bit of our time on Wednesday. Okay, we finished the return values over here. Okay, I would suggest maybe before Thursday's lecture, go over what we have covered so far. Okay, so now let's talk quickly about design principles for polymorphism, very quickly. Okay, so now let's do this slide and then we are done. Okay, just a few minutes. So now let's say in general, when you declare an attribute A of type T, so it's really a design choice. For example, do you want to make A of type students, resident students, or non-resident students? It's really kind of up to your design decision, okay? So now, basically, the idea is when you actually have T, think about the expectation for T. If T will allow you to call a feature that you always want, of course, choose T. If there might be other features that only belong to the descendant classes of T, then you may have made a wrong decision over here. For example, let's say this. If I declare S of type students, as we know very well, we can only call S.tuition, S.name, S.courses. We cannot call S.set premium rate or S.set discount rate. Right? We cannot call them. So that means, if you're expecting tuition to be called over here, dynamically speaking, it can be resident students or it can be non-resident students. It's going to work according to dynamic binding. Okay? Now, let's say later on, if you really expect, as we said before, that's kind of part of the story that we talk about. If you really are sure S is really pointing to dynamically a resident students, apparently you cannot say S.set premium rates. You cannot. But how can you get around? You got to do a cast. So I would say if you see too many casts in your code, that means you may have made the wrong decision of the type for your variable. That's one indication. For example, in the beginning of Wednesday, what we're going to do is we'll show you an extreme case where you simply make the type for your argument to be any, like objects. That's too accommodating. You are subject to so many casts in your code. That's definitely a wrong decision. Okay? Okay, so if you see too many cats, that means you may have to declare your variable to be as of type resident student instead. Okay. Okay, and the same design principle is really about what feature type you choose for arguments and also what to choose for return type. Okay. Okay, one more thing before I let you go. Okay, it's about lab number 3. So my advice would be, I'm still writing up the instruction for lab number 3. It's going to be a totally different challenge for you this time, but it's going to be the same formats for the projects. So your effort will be worthwhile. So what you should do, if you can, try to start as soon as possible. Check your Moodle announcement. It was sent out just before the class. There was a tutorial series I made. It's about 2 hours long. It's going to go over the whole framework together with you. That will save